Awesome. It's really great to see a lot of people here. Really excited. So today we're talking, well, I'm talking, you guys are listening, I suppose. Today I'm talking about Rocket. I'll tell you all about it in a second. This is me. My name is Sergio. That's my email address. You'll see it at the end of the talk again, so feel free to send me an email for whatever you'd like, any questions about the talk or anything really. And this is Rocket again. So what is Rocket? So Rocket is a web framework for Rust that ideally is supposed to make it simple to write quick web applications that are fast and performant without sacrificing flexibility while having lots and lots of type safety. And when I say type safety, think of the kind that Haskell gives you, not of the kind that C gives you. So real type safety. And what I mean by web framework is your Django's, your Flasks, your Rails, think that kind of thing. It's not like any of them really. It looks a lot like Flask, but it's not like Flask. But it's it's that class of libraries. And it is written in Rust. So I just like to get a show of hands. Please raise your hand if you know about Rust. Of course, it's a strange loop. I wouldn't expect anything else. But here's a trickier question. Raise your hand if you've written Rust. Ah, wow, that's pretty good. Excellent. Awesome. Thanks. All right, well, for those of you who haven't written Rust, or for the very small minority of you who don't know about Rust, it's a programming language that is memory safe without a garbage collector. So no dangling pointers, no double freeze, nothing like that. It's even more memory, well, you see the semantics of memory safety in Rust are even stricter than something you'd see in Java, for instance. There are no null pointer exceptions in Rust. The type system guarantees that there are no data races, so if your thing compiles, there are no data races. The runtime is very, very small, even smaller than something like C++. And it has very, very powerful macro systems. And I say systems as opposed to system because it has two. And one of them is sort of macros by example, or think of C macros, but done better. And the other one is like Lisp reader macros or procedural macros. You get an AST, it calls your function with an AST, you emit another AST, and you're done. And this last point I want to emphasize because Rocket makes abundant use of the procedural macro system. Without Rust's procedural macro system, Rocket would not exist. So Rocket is a web framework for Rust that makes it simple to write fast web applications without sacrificing flexibility or type safety. And the last thing I want to emphasize here is simple. There are web frameworks in type-safe languages, in very type-safe languages like Haskell, but they're not particularly simple. When I say simple, I mean like Flask simple, like something you'd write in Python or Ruby. Just it looks kind of like what you'd write in a dynamic language, but it's entirely strict and safe and does what you wanted to do, not what the monkey patching or mixins do. So a bit of history about Rocket. So it's rather new. Unlike Struts, which has been around for a very long time, Rocket is much newer, so it's less than a year old. It was released December 23rd last year, so about 10 months, coming up on a year. Version 0.2 was released a couple months after that, and then 0.3 several months after that, just a couple months back. And it's seen a lot of progress. It's also seen plenty of adoption. People on GitHub really, really like it. And one thing that is not on this timeline yet is how quickly someone told me that they were using Rocket in production. And if you had to guess to yourselves, where would you put a little line there? I mean, I was very surprised. The line goes right there, which is like a week after Rocket launched. And I got a message on IRC saying, hey, thanks so much for Rocket. I switched my Node application at work to Rocket, and my boss loves it. It's way faster. Thanks so much, Sergio. I was like, no, thank you for trying version 0.1. I appreciate that. So that was fun. Nowadays there's a much more calm sensation that I get when someone says they're using Rocket in production. Not so at 0.1. So when Rocket launched, it was at the top of Hacker News and the top of any programming thing. People seemed to like it quite a bit. In fact, it was at the top of GitHub's rankings that day, which was awesome. I mean, that was really great. So short lifespan, but lots of adoption. There are thousands of users. using Rocket, which is not tens of thousands, but thousands. There are dozens of companies, at least a couple dozen. It's really hard to count, but at least a couple dozen companies using in production, mostly internal stuff, but a few public-facing things. So that's the very short gist about Rocket, a web framework for Rust. The idea makes it simple to write fast web applications without sacrificing flexibility. You should be able to do what you want, not what the web framework wants you to do, or type safety. So I think the question on everyone's mind, at least on my mind when I started thinking about Rocket, was YOF. Exactly, huh? Yeah. I made this up, so you probably don't know what it is. But YOF is yet another web framework? Do we really need another web framework? Probably not, but maybe. Maybe. And so I like to put Rocket in the maybe, hopefully category. And the reason for YOF is this bad stuff here. The web is like this really scary thing that came about, someone just wrote it one day, just like, here's the web. And then it's just been evolving organically ever since because we need this, we need that, we need this. And it's, just laden with a myriad of issues. And these are some of those that sort of impact server-side web applications, which is what you write with Rocket. And some of these are sort of solved. We have very good solutions to some of these problems. So these guys in green, I'm going to say that we have really good solutions to these problems. And if you use your, a Rails or a Django or whatever, it'll take care of these for you. These aren't really problems anymore as long as you use a library that solves them for you, and the solutions are pretty good. However, these guys over here have not as good solutions. There are solutions like don't execute code that the user gives you. That's a really good solution. But it turns out to not be a thing that frameworks do for reasons. Input validation is something that no one really tackles. You just kind of do if statements, and maybe you put them in a function or something, and that's how you do input validation, but no one really tackles input validation. Authentication authorization, bunch of different solutions. No one has really like a nice way to do it, and you can argue about what nice is. And misconfiguration, if you try to configure a Rails application, it is like non-trivial. And if you do something wrong, maybe you'll get a little like debug output on your log saying, hey, the secret key is like not secret. Please fix it. But it'll just continue going and leak all your secrets. So Rocket really tries to tackle not only the things that we have solutions for, because if we have solutions, then let's just use them, but also the things we don't have solutions for, which is all these things in yellow. And sort of the way to go about this, or the way Rocket goes about this, is through three different sort of philosophies, three different ideas. And those are these guys here. So the first sort of core idea in Rocket is that a handler, the thing actually handling a web request, its declaration and the parameter types, i.e. the input that we're going to get from the user, they should contain all of the information necessary to validate and process that request. So this is Rust, this is typed, everything has a type, and the idea here is that the type should tell you everything you need to know to process a request, including validation, including everything that must be true about the world, about the request, about the world the request gives you, for that request to be processed. And so this immediately prohibits APIs of the sort that you can just take your request object and then inspect headers or inspect the data or something like that. You can't do that in Rocket, which sounds limiting, but we'll see that hopefully it's not. The second point is that, as I said, all request handling information should be typed. The web is this string, right? HTTP is a text-based protocol. You just get a string from the user, and we have to convert that string into native types in our language. If we're in Ruby, then maybe we can just do that dynamically. If we're in Rust or Haskell or any sort of more strongly typed language, then we have to convert that string into some native type in our language. And Rocket's philosophy is that everything should be typed. You should never handle strings. Everything should be typed. And finally, and this is, you can sort of argue about this third point, but I feel that decisions shouldn't be forced on you. You shouldn't have to use this templating engine or that templating engine or this way to do sessions or that way to do sessions. None of those decisions should be forced on you. Rocket can provide, hey, why don't you use this? But everything should be implementable by the user. Whatever Rocket provides, you should be able to write yourself, and it should be just as nice as if Rocket provided it for you. So these are Rocket's sort of core philosophies. Now, I'm going to give you a very quick overview of what a snippet of a Rocket application looks like. But later on in the talk, we'll do that in detail. But here's a very, very quick overview. So this is what a handler in Rocket looks like. And your Rocket applications will be composed of handlers of this nature. And the things to sort of look at here are this thing at the top here. This is an attribute. Think of attributes in Python or sort of like attributes in Java. But it's all at compile time. There's nothing happening at runtime here. And these attributes are used to declare the things that your handler is going to match against. So here it's matching against an HTTP GET request to the dynamic path with the dynamic parameter ID. And like I said, we'll talk much more about exactly what's happening here in a second. Now, the second part here is much more interesting. So this function takes in 2 arguments. And you'll see that handlers in Rocket can actually take in an arbitrary number of arguments. And so one of them is this ID parameter, and that's the parameter we saw in the URL. And so this ID parameter has type paste ID, which is an ID of some thing that you're paste binning or something. And it has some user, and that's going to be a requirement that the request must satisfy. The request must identify a valid user for this type to exist. And as a result, this handler can only be called if the request identifies a valid user. And like I said, we'll see much, much more about this in a second. And finally, the last thing I want to note here is that the types directly describe the functionality of this handler. You can read off the type signature and know immediately all the things that must be true about the world. There must be a logged in user, and the ID parameter must validate as a paste ID. And it's going to return maybe a file. So option is like maybe in Haskell, if you're familiar. It's a thing that may or may not be there. And it's going to return maybe a file. So just by reading the type signature, you can see, OK, we're probably going to fetch a paste. And if the paste exists, then we're going to return the file, and we're going to return that to the user. And oh, by the way, there has to be a user logged in for this thing to run. So this is what everything in Rocket looks like. A set of matching conditions declared at the top of the file, a set of types that declare what things must be true about the request, and then some type, some value that you return of some type that is then sent out to the user. OK, so we have all of these problems. You might say, well, are these things really a concern? Like, OK, let's assume for a second that Rocket solves these problems, or it gives me the tools to solve these problems. Well, do I even need those tools? Well, obviously. And here's 3 reasons why you need those tools. So WordPress, CV 2009, impact level 10. Impact 10 is as high as you can get. It means you can do whatever you want with the application. There's a vulnerability. Send it. It's a very easy to exploit vulnerability, and you can do whatever you want. So in 2009, WordPress, any version before 2.8.3, allowed a remote attacker to gain privileges via a direct request to 8 different endpoints. And so what this was basically a bunch of PHP files, WordPress is in PHP, that you could just make a request to, put some data in there, and then you would be an administrator. Literally, I mean, you don't need a PhD in security to be able to do this. You just send a web request, and then you're an administrator. It's very, very easy. And so what was the fix? Well, take one of the fix. There were 4 patch sets, by the way, to fix this problem. I'm going to show you 2 of them. So here's take one of the fix. And as you might imagine, it's checking, like, oh, hey, can the user actually do what it's trying to do? So here it's, maybe it's a little small to see, maybe not. Here it's just checking, hey, does the current user have the permissions that this file requires? And so you sprinkle a bunch of if statements and all, in this case, there were like 13 different files because there was an unrelated vulnerability. But you sprinkle these if statements on the 8 different files, and then you kind of fix it. Turns out that wasn't the full fix, because these files were like meant to be included in a bigger file. In PHP, you can include files. And so these were meant to be included in a bigger file, and the fact that they weren't only included, they could be directly called, was itself a vulnerability. So I had to go ahead and add another sprinkle of if statements that checked, oh, hey, am I being included? If not, just end the request. This thing is only meant to be included. And hopefully this fixed the issue. OK, but what I want you to notice is that we have to sprinkle all of these if statements around if we want to actually check anything. Why don't we just declare, like, oh, hey, we need an administrator at this point? And what's more, why don't we have the type system ensure that we can only access data if there is, in fact, an administrator. We'll see that Rocket, in fact, does exactly that. So that's WordPress. Now, Spree Commerce is an application written in Rails. It's like a shopping cart app. I think the biggest user of Spree Commerce is Chipotle. So if you've, I don't know what they sell on their online store, but if you've purchased the burrito on their online store or whatever, it was using Spree Commerce. And there was no CVE for this that I saw. But basically, again, this is very, very simple stuff. This is like a level 10 thing. Again, you can make yourself an administrator. By passing the right parameters while updating a user, that user is able to assign any existing role to themselves. And the way you attack this is by, again, just sending a web request with a particular field in a form. And the interesting thing about this vulnerability is that it wasn't just Spree Commerce. It was every single, well, not every single, but almost every single Rails application was vulnerable to the exact same thing, and it's called a mass assignment vulnerability. And this was like a pandemic, an epidemic. Just people were like, oh my God, aren't we supposed to do this, Rails? And Rails was like, yeah, Ruby's nice, but also stop doing what's nice. Please sprinkle a bunch of checks everywhere. So now if you read the section in the Rails guide, it's like, hey, by the way, the thing we just told you, it's totally vulnerable. Please don't do it. Like, fix it. This was a big problem. We're going to tell you to do it because it's really easy, but also don't do it. So it's called a mass assignment vulnerability. And it's pretty straightforward. So here you're getting some parameters from the request as a form, and Ruby, or Rails rather, will deserialize that into a hash map. And so say you're getting in this user parameter, and then what you do is you create a user, this @user thing. You create a user from the parameters passed in from the web request, right? So now your user, in Rails, your objects are tied directly to the database. So if in your database you have a role parameter that identifies whether this user is an administrator or a regular user, then if you create an object with that field and then you save it, that field gets saved to the database. And so what happens is someone passes in the form a role parameter. You don't check that the role parameter is there because you just assign everything in that mass assignment, in that hash map to the user, and you create a user. This is all dynamic. See, this is sort of what dynamism gets you. You assign everything to this user, and then later on you save it. Well, if the user passed in a role, you've also saved that role. So if the user passed in an administrator role, then you've just made that user an administrator. So what's the fix? Well, the real fix is more complicated. You have to annotate your thing by saying, oh, don't save these things. If the user passes these things in, don't save them. And by the way, those are dynamic as well. So if you happen to change the name of role to user role later on, everything breaks. But the fix that Spree Commerce took was to add one line here and to just delete role. Very effective fix. It works. And it's one line, so you met the quota there. So this is the fix. But this was a very, very, very serious problem because this is the way you do things in Rails. This is not like, oh, let me take a shortcut. This is the way you do things in Rails. And for a framework to advocate this way and then have it be vulnerable to very serious attacks is a problem. And this just isn't possible with Rocket or Rust. Like, there's no kind of dynamism like this. And Rocket even goes further and is very, 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 very strict about what it accepts from users. Obviously, we're trying to solve input validation, so it's very strict about that. And we'll see more about that in a second. And finally, I want to talk about GitLab. And this one was kind of fun to figure out what went on. So this was an Impact 8.8. It used to be Impact 10, and then something changed. Now it's 8.8. But very, very serious. Again, it allows anyone to be an admin. So they said in their blog, we discovered a critical security flaw. The impersonate feature was not properly secured. It was possible for any authenticated user, administrator or not, to log in as any other user, including administrators. So I could just be you, and that would be easy. And in fact, here's the entire attack. Here's the proof of concept. You log in as a regular user. You check your cookies for this thing called an authenticity token, and then you create a request that looks exactly like this. You send a post request to /admin/user/ stop impersonation, and ID equals the person that you want to impersonate, the username of anyone you want to impersonate, and then as the data you pass in method delete, And the authenticity token is your authenticity token because it will check that you are logged in. And that's it. Then you're logged in as the user. That's literally the entire attack. I mean, sometimes these attacks are like really clever. You have to go through like very crafty things, but this one is not that. This one is very simple. So here's the code that led to that attack, and I'm not going to make you read this, but I do want you to see sort of all the stuff that you have to write. First of all, this like skip before action, and there's other stuff that I've deleted. But this is the way that you do this authentication stuff in Rails. And the problem in this code is sort of these lines here. So for some reason, they said, don't authenticate the admin for the destroy method. Right? That's the thing that we were attacking. Not totally sure why. But do authenticate the impersonator. So I guess that makes sense. Like, it doesn't have to be an admin, but maybe an impersonator is like a different role. So do authenticate the impersonator. OK, great. So what does it mean to authenticate an impersonator? Well, if we look at the method there, well, it's an if condition. Again, always if conditions. It's an if condition. Well, you check that the session contains this impersonator ID thing. And if it does, then you check that they're an admin. Well, what's the bug? If there is no impersonator ID in the session, the check doesn't happen. And because this is Ruby, there's no type information. That just, for some reason, becomes true. And the whole thing passes, or becomes nil, I guess. And then Rails will just toss it away and say, OK, yeah, that makes sense. That's an authentication. Sure. And so what happens is that all you have to do is be logged in to what it calls destroy. And what does destroy do? Well, destroy just changes your user to the user that was passed in. And then it redirects you to the root. So very, very, very simple. Cool. So that's GitLab. All right, so these are 3 serious problems. But to much mayhem and despair and also fanfare, there is one more thing I want to tell you about that Rocket would prevent. And that's these guys here. So good old Equifax and all their social security numbers. So Equifax is written in Struts, which is a web framework for Java. And back in March, they had this CVE, which was Impact 10. And the problem goes like this. They have a parser for multi-part forms. And this is very weird. But basically what happened is it had incorrect exception handling. So something went wrong, and then it would handle the exception, and then it would execute code, basically. And all you had to do was send in a properly crafted content type, content disposition, or content length header. And then Struts would execute code in that header. And this is what that looks like, that properly crafted message. Obviously, this is long. But you just write a script, and then you can inject a command right there and send it off to the server as a content type header, and it will just execute it. So what do you put in that command? Well, one thing you can put is, hey, just give me the password file, and I'll try to run some attacks against it. But if you're Equifax, you just keep around social security numbers in tab-separated files, and then you can just cat the tab-separated file and get the social security numbers for all Americans. This sounds ridiculous, like, no, come on, Sergio, they did not do that. Turns out they did do that. And the question then becomes, OK, how do you get, great, Sergio, but how do you get this path? Well, they have a dashboard where the password is admin and the username is admin, and the dashboard tells you the paths of all sensitive files. So you combine insecure dashboards with this Struts vulnerability, and then you can just cat social security numbers. Great. So, well, not great, obviously. But great for me, I guess. Great for this talk. All right. So Struts and Equifax, not great. But OK. So this is not possible in Rust or Rocket. There's no dynamic code execution. There's no VM. There's no interpreter. So this is just like would be totally weird to ever. I mean, you can write an interpreter in Rust and execute code if you want to, but why would you? And Rocket doesn't let you do that. That's weird. So those are some serious problems, and those are problems that Rocket is trying to solve, and I think has a good solution, or at least a good tool set to solve these problems. All right, so let's talk about Rocket. Let me show you the hello world of Rocket. So here's Rocket's hello world, and this is very similar to what you saw just a second ago. And there are 2 things here. Again, there's this route attribute, which again is a description of matching conditions. So this is a get path This matches against HTTP GET request to the root path. And this is the route attribute. And the second part is the route handler. This is the thing that actually gets called when a request matches the set of conditions. So when a request comes in for the root path, a GET request comes into the root path, this hello function will get called. And this will just produce a response. Now, if you've never written Rust or you're not very familiar with Rust, this ampersand tick static thing will be like, what? That's OK. It is like what? It's fine. It's a static string. Don't worry about it. Rust syntax is OK, but sometimes esoteric. There's no return. You can just, it's an expression. The block expression is an expression, so you just return the string. So this returns a string. That's really it, as we saw before. You have this matching conditions, and then you have the handler that gets called when those conditions match, and your thing executes. And if you were to run this server, well, you would see hello world. So you go to your localhost 8000 and see hello world. And that's really all you do. Of course, you need a main function, as with any language, most languages, you need a main function. So here's your main function. Here's what it looks like. What you have to do is tell Rocket about the routes that you've declared, and then you have to launch the application. So mounting is like namespacing routes. It's taking a route and then prefixing it with a path that you want to namespace all of those routes behind. So here we're just namespacing it behind the root path, which means no namespace. But we can also change this, for instance, to /hello. And then every route inside of that sort of routes list that you see down there, this routes bang thing, would have to be prefixed with /hello in order to be called by Rocket. And finally, so the first part is that Rocket ignite that creates a Rocket structure. The second part is that mount that makes routes available to Rocket to handle. And finally, you call launch because rockets need to go in the air, of course. And if everything goes well, Rocket will print emojis. Yay! That's how you know things go well. When your application prints emojis, things have gone well. And that sounds like fun, but people on GitHub seem to think sometimes it's not fun to print emojis. I disagree. I think emojis are great. Rocket prints 3 emojis. The first emoji it prints is configured for development. Depending on which environment you've configured it for, it's configurable. It tells you all the information you need to know about your application. And then it tells you all the things that you mounted. And then finally tells you that things went well and it has launched. Now, this is the point where Rocket tries to help you with misconfiguration. One, it's very, very clear how you've configured your application. There's no ifs, ands, or buts. It tells you exactly how the configuration is, how the application is configured. 2, if anything weird happens, for instance, you're running your application in production and there is no secret key, Rocket will just abort. It'll say, no, this makes absolutely no sense. You need to fix this. Any misconfiguration, Rocket will abort application. It'd be nice if we could do it at compile time. We can't because it's dynamic information. But it will abort if it sees anything wrong. So that's basically what you write. Now, this is a very not interesting application. One thing we can do is we can change that root path at the top, that get/path, to something more interesting like get/world. And then we'd have to go to the /world path to see that. We could change that to /Sergio, and we could go to /Sergio to see that. But ideally, we can do more than that, and Rocket wouldn't be very interesting if we couldn't. And as we saw earlier, we can do dynamic paths. So dynamic paths, as we saw before, are these things in brackets at the top there. And what a dynamic segment is you match anything inside of that path segment. So anything inside of the first segment is going to match to name, and anything inside of the second segment is going to match to age. And for everything that you have in brackets, you're going to have a matching name in the function signature. So here we have name and age, so we have to have a name and an age inside of the function. If we don't have a name and age inside of the function, for instance, we have age and number, well, then Rocket would give you an error at compile time. And the error looks like this. It says, hey, there's no parameter. There's this parameter named age, and you haven't used it. Here's the function where you're supposed to use it in. Use it. And this is exactly what it emits. So we can go ahead and change that back to age. And you'll see that these things are typed, right? This is not like a string. Well, the first one's a string, but the second one's an 8-bit integer. And any type that implements this from param trait, which is a type class in Haskell, or kind of like an interface in Java, or if you want, like a superclass or something like that. It's just things that must be true about this type. Anything that implements that interface, that type class, that trait, is allowed. So here we have string and U8, and Rocket implements from param for both of those types, and so that's allowed. And the cool thing is that this handler will only be called if those parameters parse as the types that you indicate. So a string is always a string, so that parses just fine. But an age is not always an 8-bit. A string is not always an 8-bit integer. So that age parameter will only parse if it's an 8-bit integer, 8-bit unsigned integer. And only when it parses can this handler even be called, because Rocket's not going to fabricate integers. So this handler only gets called if everything validates. In this case, there are two parameters, and they both need to validate. So one nice usage of this, for instance, is when getting a path from the user. So say you're trying to write a static file server, and you need a path from the user. Well, for those of you familiar, if you get a path from the user, you better make sure that the path is safe. Otherwise, they're going to be able to read everything that you have on your system. And Rocket basically prevents directory traversal. This is called directory traversal, and Rocket will prevent directory traversal just by asking for a path. So here, we've changed the dynamic parameter to have dot dots, and that just means not only this segment, but every segment, because we want to match the entire path. And then we've specified that the type of that parameter is a path buff, which is just a heap allocated path. And then the implementation of from param for path buff will ensure that that path is safe to be used as a suffix to any path. So here we can just open a file at that path prefixed with static and return it. And if that file exists, the user will get the file. If the file doesn't exist, then we'll get a 404. And this is exactly what you write. These 4 lines are exactly what you write if you want a static file server in Rocket. And it is not vulnerable to directory traversal. And again, the types tell you exactly what has to be true. This has to be a path, and nothing will get called. If that path is weird, wonky, the user will get an error and say, nope, that doesn't make sense. Please fix it. OK. So request guards are my favorite part of Rocket. I think this is where all the power comes in, really. So Rocket has this concept of guards, and these parameters, you can call them parameter guards. And so there are different types of guards. So the parameter guards that we saw before, and now request guards. So request guards are types, again, that guard your function. So here, your handler. So here we have a guard called admin user. And you can have as many of these guards as you want, an arbitrary number. And again, like I said, these guards will validate the incoming request against any arbitrary policy, and they protect the handlers from being called erroneously. If there is an admin user logged in, then that guard passes, and it allows that request to go through. If there is not, then that guard does not pass. In fact, it has 2 things it can do when it doesn't want it to pass. It can either fail. It can say, hey, Rocket, this is not a good request. Fail it, stop processing it. But it can also do something called forwarding. And forwarding it's kind of like indicating a local failure. It's saying, hey, this does not validate an administrator, but maybe something else can validate this request for some other thing. So for instance, you might have another route that has a regular user. And what Rocket will do is it'll try these routes in what's called ascending rank order. So when routes collide, that is, they match the same requests. So here they both match get request to /admin. It'll try those routes in ascending rank order, and you have to specify that with this rank equals rank, in this case 2 parameter. And if you don't, for instance, if you did this, then again you get an error. This time at runtime, because routes can be generated dynamically, and it'll tell you right here, hey, these things collide. Here are the names of them. By the way, did you know about ranking? That usually fixes this problem. And so yeah, you have to rank them. And so you rank them, and Rocket will try them in ascending rank order. So if we have these 2 routes, the first thing it'll do is it'll try that route at the top, which means it has to validate an administrator. And if that doesn't work, it'll try that second route, which means you're going to need a regular user. And you can extend this further, for instance, to say, well, I don't even need a user for a given route to run. And what we've done here is encode a policy. Authentication and authorization is encoded in these 8 lines. Right? If there is an admin, you give them the admin panel. That's the first route. If there is no admin, we try that second route. That means, hey, I need a regular user. Maybe you give them an error that says, hey, I'm sorry, this is only for administrators. And finally, if there is no regular user, if there's no user at all, then you try that third route. And this one has no requirements. It has no parameters in the function signature, which means nothing needs to be true for this to run except the matching conditions. In that case, maybe you redirect them to a login because we don't know. They may be administrators. So this is encoding an arbitrary policy through request guards and forwarding. All right, the last thing I want to talk about, sort of the world of Rocket, is this data guards thing. This is sort of the thing that would have prevented the Equifax attack. So say you have some structure, and it's some task here. So think of this like C++. Say you have some structure, and it's a task and it has two fields, a string and a Boolean. And you want to parse a form into this structure. Well, what do? Well, you use a data guard. And this is what you would write, for instance. We've introduced this data equals, in this case, we're calling it to do. And what happens is Rocket will look at the type form, and we'll look at the generic parameter task. Well, not Rocket, really Rust. And as long as that task implements another interface called from form, things will be OK. It'll allow this to type check. And so how do we implement this interface? Well, you could write it manually, but also Rocket could generate the implementation for you from the fields in the structure. And the way you do that is by adding that derive from form thing to your structure. And Rocket will look at the fields and generate the code to parse any form as that structure. And it's very strict. If there are any other fields in the form, it'll fail. If there are fewer fields, it'll fail. If the fields are the wrong type, it'll fail. So you have to get exactly that structure for this to pass. Now, there are escape hatches, for instance, because like APIs like to give you more fields than are actually there. Like Stripe just gives you fields that they've never documented. So you need some way to say, OK, accept more fields, but never less fields and never fields with the wrong type. And any type that implements this from data interface is allowed. So, so in this case, for instance, we have a form type that Rocket provides, and it implements from data, as long as the generic type implements from form. And like I said, Rocket will automatically deserialize that into the structure that you'd like. And you can change that form, for instance, to JSON. And all you have to do is change the type, and all of a sudden you're deserializing JSON. And everything else happens for you. OK. So this next part I'm going to run through very, very, very quickly, because for those of you that know Rust, this will be interesting. For those of you that don't know Rust, this will probably be confusing. So I'm going to go through it very quickly just so you have an idea of what's going on here. So how does Rocket do? What does Rocket generate? What code does Rocket generate to do all its validation for you? So here is the hello world revisited, and here is the code that Rocket generates. This thing up here is generated from the attribute. It just reads off the things in the attribute, and it generates a structure that has the name, the method, the path, and then a handler, the function it's going to call. And you'll see that the name of the handler is not the name of the function. So that's another function that Rocket has generated. So this is high route thing. And what it's done, it's monomorphized your function. So it's taken any function and made it one signature as opposed to many signatures, which we can't call. And finally, on this mount thing, it's expanded that route's bang into a vector. Like I said, I'm just going to go through this pretty quickly. So this is the code that it generates. The fun thing, like I said, is this monomorphization takes your handler and expands it into another function that has a static signature that Rocket can call at any time. So what does it do about guards and parameters? This is much more interesting. First, the attribute stuff, that's exactly the same. It just reads off the things inside of the attribute and generates a structure, which it's going to use at runtime to actually know what route this is. But this part is much more interesting. Well, the code that it generates is pretty big. It's this stuff here. And I mean, it kind of does exactly what you would write. Right? These are these if conditions that we saw. It just writes them for you. So for instance, it calls this from request method for you automatically from that from request trait. And it calls that from param method automatically from that from param trait. And so really, it's just generating the code that you would write yourself. There's no magic, just code generation. So this is the 3 bits of things that it covers. All right, so one last thing on Rocket. So this is type URIs. So this is a new addition to Rocket. So say you have a route like this, and it has some path/inventory/product/ID, and you want to generate a URL to this path, to this route. Well, you could just concatenate a bunch of strings together and get this shirt of ID 2417. But better than that, Rocket provides this macro called URI, where you just give it the actual type that you need, so this is type safe, and it'll generate the path for you. And you can also specify them as key value pairs. So you can do product equals product, ID equals ID. You can flip them around. But if you get it wrong, for instance, if you call product item when it's actually product, then Rocket gives you a nice compile time error. And it says, hey, these are wrong. This is what I thought it was. This parameter named item, I don't know about it. But you are missing this other parameter, so fix it. So if you go back and fix it, it generates this URL for you. Okay. Finally, on performance. Rocket's fast. Rocket's pretty quick. Here's how quick it is. So there's Rails, there's Express, there's Flask, and there's Rocket. So Rocket is several magnitudes faster than Rails or Flask, and it's quite a bit faster than Express. In this case, tens of thousands of requests faster. This is on a rather slow machine. So don't take this for granted, or don't take this as the truth. If you ran this on a faster machine, you'd easily get hundreds of thousands of requests from Rocket. What's more interesting is what happens with latency. So if you look at latency, so all of these other languages are garbage collected. If you look at latency, Rocket is just way lower. Here, lower is better. So Rocket is sub a microsecond. Everything else is, many microseconds. And this is the average latency. When we look at max latency, if you saw that tail at scale talk, we should really care about that. Then Rocket is just really low. And this is, at this point, this linear graph becomes a very bad graph. So you have to go to this logarithmic graph, and then things look even more crazy. Rocket actually goes to the left of that graph now, because it's the only thing sub-microsecond. And if we were to plot both average latency and max latency, then it becomes very clear that Rocket is in a whole different ballpark as far as latency is concerned compared to anything else that you might use, sort of in the same usability category. This is a summary of performance. So quite a bit faster in throughput. It's going to get much faster, and it's quite a bit faster than most things. The latency is way lower, especially in the max case. And yeah, Rocket's pretty quick. So that's all I have to say about Rocket. If you want to learn more about Rocket, there's a website. If you go to rocket.rs, there's a guide, there's a tutorial, there's a bunch of documentation, there's news, and obviously a link to GitHub. Check it out. It's, like I said, there's thousands of users, dozens of companies. I'd love for you guys to use it. My name is Sergio. That's my email address. Thanks so much for your time.